All right, so let's look at 12.4. This is a standard interest in the bank, money in the bank problem. So they say you invest P0, that's the principal at time zero, at 7% annual interest rate, and it's compounded continuously. How long will it take for your money to double? How long until you have 2 times P0, whatever P0 is? You put in $100, how long until you have $200? Doesn't matter how much money you put in, the doubling rate, how long it takes to double, will always be the same. Okay, we have two options whenever you have a problem with money in the bank. We have two formulas you can use. The one, P equals P0, 1 plus the rate divided by the number of times it's compounded annually to the number of times it's compounded annually to the T power. Or you can use the amount you have is P0e to the rate times time. This one, it's not continuous. It's compounded every quarter, every day, and if you call a bank, they don't do it continuously. They don't do this formula. They use this formula, but typically they use an n that's small enough where it really doesn't, or big enough that it really doesn't matter that much, like they do it every day. And if they do it every day, you get practically the same thing. So this is the best one. You want them to do it continuously, but it's about the same. Here they say continuous. They're not saying they compound it 4 times a year. So in this time we use this, where now, since it is continuous, the rate here, R, is 7%, but we always do math with decimal, so it's 0.07. So they tell you that. That's the easiest way you can do it if they just tell you it's 7. So what's the doubling time? So then you just say, okay, when do you have 2 P0? How long until you have 2 times P0? Double the amount you put in. So the amount you have in the bank is twice what you started off with, which is e to the 0.07 t. The P0s cancel, doesn't matter how much you start off with, and now you just solve for t. And you do that by taking the natural log of both sides. So let's just go ahead and do that. So ln of 2 is equal to the ln of e to the 0.07 t. ln and e cancel, that's the whole point, they're inverse functions. So ln of 2 is equal to 0.07 t, or the doubling time is t is equal to the natural log of 2 divided by the interest rate, which it will always be that way. So any further problem they ask for the doubling time, it's always the natural log of 2, because that doesn't matter. That's the 2 is gotten from, we said, doubling time divided by the interest rate. If they'd wanted the tripling time, it'd be do the same math, you'd get the natural log of 3 divided by the interest rate. If they want the quadrupling time, natural log of 4 divided by the interest rate. It's a real easy formula. Once you do the math once, you just figure that out. Oh, the 2 came because we have twice as much money. We had 2 P0. If you want the tripling time, you do that. Okay, so then that's easy to plug into your calculator. Natural log of 2 divided by 0.07, and I get 9.9, and this we're talking about years here, the annual interest rate, so years. So it'll take about 9.9 years, about 10 years. So if you get a 7% interest rate, you put your money in the bank, in 10 years you'll have double that. You put in $100, about 10 years later you'll have $200. And if you have a better interest rate, it'll be shorter, right? You divide it by, whatever, you just change the interest rate in the bottom, and that's how long it'll take. So real easy formula, and pretty easy way to get it. All right, so then let's look at B. So they say, suppose you invest P0 at R% annual interest rate, and the future value is computed by continuous compounding. If you want the value of the account to double in 2 years, what's their interest rate? Okay, so now they say we want to have twice as much money in 2 years. What must the interest rate be? Okay, so so let's see, we'll write down our P equals P0e to the RT. Now we want to solve for R. We want to have twice as much money. So we say, okay, twice as much money, we have 2 P0s is equal to P0e to the R, and the time is 2 in 2 years. Again, put the P0s cancel. Take the ln of both sides. ln of 2 is equal to the ln of e to the 2r. ln and e cancel. ln of 2 is equal to 2r, or r is equal to ln of 2 divided by 2. Looks right. So we do that in our calculator, 2 divided by 2, and I get 0.34657. Where do I round off? I don't know. Which was about, what, 34.7%? Something like that. 34.6, I don't know, let's just say 7%. So if you want to have twice as much money in 2 years, you'll need an interest rate of 34.7%. Now, we could have used our formula from up here and just solve for the rate. The rate is ln of 2 divided by time. Or we could just start from scratch and do it this way, which isn't that hard to do. Okay, so that's how you do those. Just really simply, again, using the formula. Now for part C, they say that there's this rule of 70, and and you're just supposed to show that this formula, that T is equal to 70 over R, predicts the time it takes to double an investment. And it's just a rough thing here, right? 70 over the rate is the time it takes to double the investment. That's a lot, so you can just quickly do that in your head, right? The time it takes to double is 70 over the interest rate. So let's see if that works. Earlier, we said it takes to double if the interest rate's 7, it takes 9.9 years. So let's see if that formula works. So 70 over 0.07, that is 10. And we said 9.9 and we got 10. Well, gee, that's pretty good. Now we know that if the interest rate's 34.7, from our just example, it should take 2 years. So let's plug that in. So the time, if the interest rate is 34.7, well, 30, that's about 35, and 70 divided by 35 is 2, so that's about 2. So it works. So roughly, if you want to know how long it takes to double your money, it's just about 70 divided by the interest rate. These days interest rates are really, really low, and so it takes a long time to double your money, right? If the interest rate's 1%, it takes 70 years to double your money. Okay, that's 12.4. Hopefully that made sense to you.